Good morning, everyone. So I am back. Our lesson this morning is about geometric sequence. So our objectives for today are as follows. First, illustrate a geometric sequence. Second, differentiate a geometric sequence from an arithmetic sequence. Third, determine geometric means and the nth term of a geometric sequence. Let us begin. For our first topic, we're going to have the difference between arithmetic and geometric sequence. So let's have a comparison. In the learning tasks of your module in number 2, we have 3, 6, 9, 12, 15. This one is an arithmetic sequence, while problem number 1, 5, 10, 20, 40, 80 is a geometric sequence because number 2 is obtained by by adding 3, while number 1 is obtained by multiplying by 2. So that's it. So when we say arithmetic, we're going to add. It's either positive or negative depending upon the given. And when we say geometric sequence, we are going to multiply. So it says here that an arithmetic sequence is a sequence where each succeeding term is obtained by adding a fixed number, and that fixed number is called the common difference, denoted as letter D. Whereas a geometric sequence, also known as geometric progression, is a set of terms in which each term after the first is obtained by multiplying the preceding term by a fixed number also, and this time we called it the common ratio or R. Examples of geometric sequence. Okay, here so we have 1, 2, 4, 8, 16, 32. And as such, we call them as a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. As you notice, 2 here is multiplied to any term to get the next term. So we say that the common ratio is 2. So if we check it, 1 times 2 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So a ratio can be an integer or fraction, maybe positive or negative. And so to get the common ratio, it can be found by dividing any term by the term that precedes it. So we have the formula to find the ratio is R equals A sub 2 or over A sub 1, or it can be any term, any two consecutive terms. So more examples of geometric sequence we have here 1, negative 3, 9, negative 27, 81. So the ratio here is negative 3 because negative 3 divided by 1 is negative 3. Another, we have negative 24, negative 12, negative 6, negative 3, negative 1.5. So here R is equal to negative 24 over negative 12 over negative 24, or 1 half, well, we'll use the lowest term, or 0.5. That's one example. 960, 240, 64. So we have here R equals 240 over 960, or 1 over 15. Simplifying by dividing 1 by 15, we get also 0.066. Okay, so you notice that for the sign of the ratio, look at the pattern. I will give you some tips. So you see that the signs here are alternate. So So number 1, we have positive, negative, positive, negative, positive. So the ratio, the sign of the ratio is negative. Here for number 2, there is a pattern. All terms are negative. So the ratio is positive. I forgot to indicate here negative. So may negative po yun mga laka. And then here the geometric sequence is in decreasing order. So you notice that the ratio becomes a fraction. If it is increasing order, the ratio is a whole number. Okay, let's proceed to topic number 2, which is finding the terms of a geometric sequence. So to find the terms of a geometric sequence, first you find the common ratio and then multiply it to each succeeding term. Examples, so find the common ratio and the next 3 terms. So we have 3, 6, 12, 24. So you get 2 numbers that are consecutive. So here I choose 6 divided by 3, which is 2. And then from 2, I will multiply, from 24, I will multiply the common ratio. So that's 24 times 2 is 48. And then continue, 48 times 2 is 96. Then one more, 96 times 2 is 192. So we have the answer. The next 3 terms are 48, 96, and 192. Okay, one more. We have 0.1, 0.3, 0.9, and 2.7. So I will get the first 2 terms. So the 0.3 divided by 0.1 is equal to 3. And then I will multiply 3 to 2.7 being the last term. So that's 8.1. Then continue. So we have here the answers 8.1, 24.3, and 72.9. Yan. So we have now the third topic, which is finding the nth term of a geometric sequence. To find the nth term of a geometric sequence, we use the formula a sub n is equal to a sub 1 times r raised to n minus 1. Where a sub n is the last term or the nth term that we are looking for, the indicated term. A sub 1 is the first term, r is the common ratio, and n is the number of terms. And so, well, let's have the example. Find the 8th term of the geometric progression, 1, negative 3, and 9. So let us identify the given. Here we have the first term as 1. And then the ratio is obtained by getting 2 terms. So here I got negative 3 divided by 1. So that is equal to 3. Negative 3. Now, for n, we have, okay, balik natin. For n, we have 8 minus 1 is 7. So, 7 po siya mga laka. So, now substitute. Yan. So, 8 minus 1 is 7. Okay, so substitute pa po natin siya. Okay, so simplifying, we have the 8th term is negative 2,187. So you follow the order of operations. So I start with the 1 inside the parentheses. So that is the ratio. And then simplify the exponent. So 8 minus 1 is 7. And then raise negative 3 to the 7th power. So multiply it 7 times. Negative 3 times 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 negative 3 is negative 2,187. And that's the only time you multiply it with a sub 1. So here it is times 1. So you got the final answer. Another example, find the 10th term. So we have 1/2, 1/4, 1/8. So similarly, you identify the first term, which is 1/2. And then to get the ratio, get two terms. So we have 1/4 divided by 1/2. Rewriting this into 1/4 times 2/1. Since to divide fraction is to multiply its reciprocal. Then 1 times 2 is 2, 4 times 1 is 4, reduce 2/4 to lowest term, we got 1/2. So the ratio is 1/2. And then substitute it to the formula. We are looking for the 10th term. So 1/2 the first term times 1/2 the ratio raised to the exponent n is 10 minus 1. Okay, so simplifying, we'll get this. And so finally, we have 1/1024. Or you can expand this without using the formula. You may do so. So multiply the first term by 1/2 and so on until you reach the 10th term, which is also 1/1024. Okay, either of the two, depends upon you. You are free to use whatever solutions that is best for you. Okay, so that's it mga anak. So I hope that you learned something today. So thanks and bye-bye everyone. So keep safe always. Love you all.